Math 2. This is Unit 7, Lesson 2, Practice Problems. So let's take a look at number 1, angle AOB. Okay, so angle AOB is this central angle right here. And they're telling me that my central angle is 56 degrees. So I happen to know that its arc, AB, is also 56 degrees. So this brings me to my inscribed angle, ACB, and that's the measure that they would like. So the measure of my angle ACB, since it's an inscribed angle, should be half of its arc. So it should be half of 56. So it looks like ACB would be 28 degrees. And C really could be anywhere on my circle. And if I connected its endpoints to AB, it would always be a 28-degree angle. Explain the difference between a central angle and an inscribed angle. So we've wrote that definition down a couple times. You can check for mine in the locker. So number 3, it says, what's the measure of the arc from A to B? So I'm looking for this arc from A to B because it says not passing through C. So I'm not talking about the other side of the circle, the major arc, the very large arc going from A through C up to B, but the red arc. So in this one, I have an inscribed angle of 40 degrees. So my arc should be twice of my inscribed angle. So this arc must be 80 degrees in order for the angle to be half of it and be 40. So remember, this to me looks like a diameter because it goes through the center. So I know that this entire A to C, that entire arc is 180 degrees. So if this portion BC is 80, then I know that the AB portion is 100 degrees. So I know that the answer is C. Something separately I wanted to talk about is this angle B right here. Sometimes kids see this situation where B is an inscribed angle and they get a little confused about it being a right angle. I want to talk about that for a moment. This entire arc over here is 180 degrees in order for a circle to be 360. So when you have an inscribed angle on a diameter, it's always going to be a right angle. It's always going to be 90 degrees because remember, an inscribed angle is half of its intercepted arc. So if it's intercepting a semicircle, it's going to be half of 180, which is 90 degrees. So that's kind of an interesting thing to make sure that you know. So let's take a look at the next page. So this goes back to central angles from lesson 1. So if my arc is 50 degrees, my central angle is also 50. If this entire line is a straight line, is a diameter, I know it's 180. So 180 minus 50 is 130. So I know those two have to add up to 180. And I know Z has to be equal to its central angle. And so since those angles have their vertex on the center, they're equal to their arc. And I know this arc would be a semicircle over here. It'd be 180 degrees. Matching vocabulary, a chord that is not a diameter, meaning it doesn't go through the center. That looks like, getting a different color. This looks like my chord. It looks like Y is my chord. And then it says a diameter, well, X looks like it's my diameter. X goes through the center. So that one looks like it goes together. My radius, a radius. Well, there's multiple radii, but the only one that is identified for me clearly is W. So W would be my radii in this picture. And lastly, my central angle. My central angle is my angle that has a vertex on the center. So it looks like that would be M. And then look at the next page. Again, this intersection of the medians, I believe there's a formula on our formula sheet, but before school closed, we had gotten to lesson 14. So I don't believe this had been covered. Feel free to take a look at that at the formula sheet if you'd like to. And then lastly, also going back to previous unit 6, but our lesson 11, perpendicular lines could be denoted when we flip-flop our X and Y and make one negative. And so C is the only one doing that. And because I needed the negative in front of one of my x or my y. And so this one would be a perpendicular line and also a dilation. It just means my line got bigger, I guess, if you want to think about it that way. Thank you very much for tuning in to Unit 2 practice, or Lesson 2, Unit 7, Lesson 2 practice.